Andrei from him, and today I want to. Man, this is complicated. And today I want to give you a short tutorial for GT examples. This is a very tiny framework for Pharo, whose purpose is to create examples that then can be used for documentation and testing purposes. And you already saw some examples a bit before, but today in this talk I want to focus more on the difference between examples and the unit tests, and then look more at the economics of designing our unit tests to also serve as examples for our system. And for that, I do not have any slides. I will just use ESUG, the one that you saw in the morning. Okay, you can look at it in the browser, but that would be actually terrible to do, so we're not going to do that. Instead, we're going to switch to a Pharo image, where we have the same ESUG open. So let me just see that we can make sure it's on the whole slide. No? Let me know if it's cut on any of those slides, otherwise you will not be able to see. Super. So first, in this tutorial, we need to write unit tests and examples, but we need to write them for some kind of application, otherwise, yeah. So for that, I wrote a very tiny demo application, whose purpose is to just use the Azure Face API in order to highlight faces, identify faces, and highlight them within images. And if we go through the document, I have here a small snippet of code that I can execute, and that will return back the actual running applications. So right in the document. So this is more or less consists in a list of faces that I'm downloading from the internet, then calling the API, getting back the faces, and then highlighting them. And this can be done as you scroll through. Okay, so this is quite a simple application, doesn't do much. And then if we go and look at the internals of it, the application is designed using a very, very, very simple object model. So more or less we have two main objects. So there is picture and face. The picture is the object that holds the graphic representation and has the list of faces. And then a face just holds information returned by the API. So for example, the rectangle that delimits the face, and then certain landmarks that identify, for example, the eyes, the nose, and the mouth within the picture. Super. So now, let's go next and just create some simple tests for our application, and we'll just start with checking that, for example, picture and face are initialized correctly, and then that we can add faces to the picture. So for this, I'm just going to use the fact that we can embed in we can embed in the document epicheia changes. So here I have a piece of code, that's an epicheia log. So we can see that to create a test, we create a test case, then we add a protocol, and then we create a test method, test face initialization. That just creates a face object, sets a rectangle, and then has some assertions. We can always have the diff, and the diff view will show us the state between this code and the code of that's currently in the image. So here we say, okay, this code is not in the image, and I want to apply it. I want to add this test. And now the diff view disappears as there are no more changes. It's in sync. Now that we have a test, we can run it, and we can run the test runner directly and embed it here. Why not? And now we can see that we have a test runner, and we have one test, and it passed. So super. This is a good start. Next, let's cover also the initialization of picture object. So now we have a test picture initialization where we just create an empty picture and then check some properties in the assertion. Again, if we go to the diff, we can see that this is all new code. So let's apply. Next, we'll add a few more tests, but I'm not going through them. So this more or less will verify that we can add faces to pictures in various conditions. Apply.
Excuse me, is it possible to make the font a bit larger?
Not really, but maybe the resolution.
The ratio is also not really.
So the projector is less than ideal. It's not better, or? It's better? Does it still fit in the screen, or? Okay, let's better. This is a game. Better? Because, okay. Still? Ooh. Super. Okay. Problem solved. Okay, so now we added some tests, and now we can check again if they are running or not. And now we get 5 tests, and they're passing and they are green. Next, we can...
Sorry, a question. What we are seeing there, is it a PNG of the morph?
So right now, So right now, the test runner is written in Morphic, and we just run it and get the... It's actually, you get the object as a system window, so this is an inspector on the system window, and then this is the morph view that shows the PNG of the actual inspector. When the test runner will be written in a block, we can just embed the test runner directly inside. And now, let's do the same. Let's go to the same use cases, and now instead of creating tests, let's just create examples to verify the same aspect that we did before. So first, let's start with the initialization of empty face. So for that, for the very beginning, so this is not yet an example, I will just create a class to hold the examples, and now let's just add a method that initially is just as identical to the test method. So this is just a different name, but it's exactly the same code as before in the test method. So this is not yet an example, but we can just apply it. And now let's look at a div that will show us what we need to change in this test method to make it an example. So here, all we need to do is add an annotation. So we need to tell for the moment somehow the framework that this method is an example. So treat this method as an example, because we can have a lot of methods and we don't want all to be examples. And then, most importantly, we need to return from this example method an object. Because if you think at what a test does, so a test creates an object, configures it, runs some assert, runs some actions on it, checks some assertions, and then completely throws that object away. So it goes through a lot of effort. We go through a lot of effort in tests to create objects, and then we just throw them away like they never existed. With examples, we say let's don't do that. Let's return them and see if we can build on top of them further. Okay, I will apply this, and now we get the first example method in the image. And now we can try to do the same as we did for tests. So if we have some examples, we should be able to check that they are actually running. In the case of tests, we have the test runner. In case of examples, we can just inspect them. So I will create an example group. I will just put the current example there. And then, now, if I inspect it, now I am actually getting a live runner for examples. So before was just the PNG of the test runner, but this is just an inspector. And I am inspecting an object of type example group that has an examples view that shows me the list of examples, and then if I click on the run, it will execute those examples right in place. So I can embed in the document just a runner, check a runner for examples to see if they work or not. And next, let's write a few more examples. So this one, it's exactly the same as before for testing the initialization of an empty picture. So I need to add the annotation, I need to return the picture, but otherwise the code in between is exactly the same as the one in the test. Nothing changed here. Let's apply. And let's go just through the details of one more example. So this tests an example faces, the picture with faces and no form. So here I'm creating a picture object that doesn't have any graphic representation, and I'm just adding some face objects to it. Now, to create the faces and to create a picture, I can actually rely on the previous example method. So we already had the empty picture method, that was an example that was creating the picture, and then we have 3 methods that create examples that are for creating each individual face. Okay, so then to build this, we can just apply, and now we have them. And let's create a few more, but we'll not go into details. So this tests again a few more examples for different kind of faces and pictures. And now we can run them again. We'll get a few more this time, and if we try now, all of them pass. So hurry. Now let's go back for a second at the test runner. So if we take a look at the test runner, so here actually the way we are supposed to interact with the test runner is that we run the test, and then when assertions are green, we stop. So the moment tests pass, we are no longer interested in the test runner. Our interaction with those tests stops. That's by design. But in this case examples of tests can be quite interesting. So why stop at the moment just when assertions are green? Why not let that be the point where we start our exploration, our interaction with examples? So by default here, I can select an example, and actually right now I'm just in an inspector, so I can always, so let's double select it, and now I can always choose to continue my exploration with this example. And now let's look at 3 ways that we can continue to interact with examples once assertions are green. So first, has to do with exploring the static dependencies between examples. So in this is an example for a picture with faces and form that calls other examples. So we call, for example, picture with faces and no form that then calls others and others. And to get, for example, a quick overview, we have a graph view. This is very simple. Its only purpose is to give us an overview of the steps needed to build this object. So what were the other examples, the steps that we need to take in order to create this? So we can check. So okay, first this is the main one. Then first we need to create a face that has no form. Then we need to create actually an empty picture, and then we create the tree picture. So we can just easily look from a very high level point of view of what were the steps needed to make this object, to initialize and construct this object. But now, what we want to do is go more into the details of source code, and you saw part of this in the morning. We can maybe just focus on this, and then in the source view, we can always expand in place source code for examples. Just to get a more of an overview, and maybe to read the overall code, because it can end up that we have the code in multiple methods. This helps. And then, of course, if what we want to do is do both, also get the overview, and we also see the code, we can go to the connections, and here just explore, in place examples, and also see the code, their dependencies. But of course, it helps if you have a bigger resolution. Now, if we go back, until now, we just looked at the static aspect of examples, so their dependencies. But while this is okay, it's not the most interesting thing about an example. More interesting is actually the object that it returns, because we are building one and then returning. So for every example, we can choose to execute it and get back the object that example creates. So in this case, I execute, I get back a picture, and a picture just has a view that shows me the picture, and actually in this case will highlight the faces that were detected. I can also look at the list of faces, and I can always choose to continue navigation in the inspector, if that's what I want to do. So we can use examples to actually capture what's interesting objects from our domain, and then combine with presentations from the inspector, just view and reason about the domain in different ways. Let's look maybe at one more interesting one, picture with faces and no form. Let's try this one. Okay, so this is actually a funny object. So here we have the picture, we have the position of faces, but we do not have the actual graphic representation. But we can still show quite a useful view. In this case, just to get a relative position of faces one to another. Yeah, so this is the second aspect in which we can continue our interaction with examples. So first was to look at the actual their static structure. Second was to look at the objects that were created by those examples. And now we can also do a third. And the third we also saw it this morning is related to trying to specify documentation in a different way. Let's just add a few more examples before we go to this. Now there are a few more. Yes, so every time we create software, we often need to write quite a lot of documentation, either to explain to ourselves what we're doing, or to document maybe an API, or to explain to others how to use our systems. And here we often end up doing two things. First, is copy-pasting snippets of code in the document, and second is taking screenshots and embedding those screenshots to highlight different usages of our application. But actually with examples and custom inspector extensions, we capture both aspects, the code and the actual representation. So we could use them to create more live document instead of more testable document instead of this copy-paste and taking manual screenshots. So now this section, using faces and picture objects, is just supposed to be a short documentation for how to create a picture, how to create an object, and how to link them together. And most of it just contains some text and then embeds some examples. So they just quickly go through it to see the ways in which we could embed an example and interact with it. So first one simply says, okay, what describes what we need to do to create a face. So we instantiate it and we send rectangle to set its actual contour. And here we can use this syntax to embed an example method, and we're embedding the picture example, and this is the method. And by default here we chose not to have it expanded. If we want, we can expand it and see the source code. For the next example, the one that shows how to add landmarks to a faces, we chose to actually embed and show by default the source code. And now, in both cases, we could execute and get back the object returned by this example. So in the first case, we get back, and then we have the entire object. I mean, this is nothing interesting. But in the second case, maybe not all the time we want to embed the inspector. Sometimes, maybe just the view from the inspector is interesting. So if you look here, it says show GT face landmarks view. So if we execute this, we don't get back the entire inspector, we just get back the view in which we were interested in. That's it. So like that, if we define a lot of custom views, each capturing different aspects, we can simply embed only those views within the document. Right now we're embedding one, and it could be one to embed more. So let's continue. Now we're creating a face where we also have a graphical representation and landmarks. And in this case, we chose to do both. So we chose to show the preview and also show the actual graphical representation. But at any time, we can just collapse if we're not interested in this one. Next, we create an empty picture. So this is again the same example that we had before. Then we add faces to a picture. The picture doesn't yet have a graphical representation. And finally, we also attach a graphical representation to this picture. And now we have our final example from the document. So here, actually, the text that we had to write was quite little, just a little. We were just describing the main steps, and then at every step, embedding an example to show the source code needed to perform that step, and then embedding an inspector or a view to show us a representative presentation or aspect of that object. And this kind of covers most of the things I wanted to show you. So just to wrap it up, we looked at 3 different ways to interact with examples. First was, okay, we could explore the static structure between examples. Second was to look at the objects that were created by examples. Third was to take those examples and embed it in other places. In this case, it was to embed them within a document. So examples are not there just to verify that code works as expected. They can actually serve as a foundation to help us build stories, to better explain first to ourselves, to other developers, and also to business stakeholders alike, all the complex and intricate details of our software systems. So there are quite a lot. And also, to make this possible, it's not just about adding a custom annotation to a test method and then changing that test method to return an object. That's part of it. But in order to take full advantage of examples, we have to change more. First, we should change the way we approach more testing. So we focus more on actually building examples instead of just testing functionality. And second, and most important, we should also change more even than this, our development tools, to more fully embrace examples, instead of stopping, like we do now, all the time when assertions are green. Okay, so this is what I wanted to talk to you today. If you have any questions,